we're given pressure and temperature, and those two conditions, pressure and temperature, change. On this one, T and P, pressure and temperature, are the ones that are changing. So I'll just move them over to the left side by dividing by T. So that'll give us P over T, and then I'm going to move volume over to the right side along with the other two constants because the number of moles isn't changing and R is already a constant. All right, so volume and moles are the constants here. I'll also divide by V, so that'll give us N R over V. Now, because this side is a constant, what that means is that value is not going to change for this gas. We can rewrite this expression as P1 over T1 is equal to P2 over T2. We need to convert these temperatures into Kelvin. We need the absolute scale. Can't have negatives and zeros here because these are all proportionality laws. They don't have negative values. Pressure, temperature, pressure, volume, number of moles are not going to be negative, and neither should temperature. To convert Celsius into Kelvin, we add 273. Let me try that again. That's going to give us 303 Kelvin. And if we do that here, 101. Negative 172 plus 273 is 101 Kelvin. This is T1, by the way. And this is T2. It's decreasing in temperature. It turns out this is 3 times as great as that. So the temperature is 3 times as high on the Kelvin scale before. You also know that P1 has to be 3 times as great as P2. All right, so we already know the answer to this because P1 is 300 kilopascals. Then this must be 100 kilopascals. You probably wouldn't write it. We need 3 sig figs on this, so you would probably write that 1.00 times 10 to the 2 kilopascals. And that's your answer. Now, let's actually calculate this out. Let's just resume from here. It's asking us to solve for the final pressure. So let's rearrange this to solve for P2. P2 is going to equal P1 T2 over T1. Now we can just plug our numbers in from before. P1, that was 300, I believe. Yep, 300. Or 3.00 times 10 to the 2 kilopascals. T2, 101 Kelvin. And T1 was 303. It was 3 times as great, I remember. This is just 1/3 of 300 is 100. So you get the same results. And we'll write 100 in scientific notation. 1.00 times 10 to the 2 kilopascals.